Okay, I'm just going to go through the examples here in your notes. So the first one is 1 over x squared plus 2x minus 3 dx. I'd always check, do you have a derivative on the top? And this one I don't, so I'm stuck. I can't do anything. So what I'm going to do is I'm going to take the bottom and I am going to try to write that in partial fractions. So if you consider 1 over, if you factorise that first, because you're going to try the partial fractions, what multiplies to give 3 and adds to give 2. So it's a plus 3 and a minus 1. So a over x add 3 plus b over x minus 1. I'll have it the other way around in the notes. I'll just keep it the same as my notes here. So it's a over x minus 1 plus b over x add 3. So just to keep it consistent with the notes you have uploaded, or I have uploaded there. So sorting out the tops, just your standard way. Choose x to be minus 3. So it's 1 equals, that disappears. So it's minus 4b. So b is minus a quarter. And then choosing x to be 1. So it's 1 equals 4a. So a is a quarter. So instead of having the integral of 1 over x squared plus 2x minus 3 dx, I'm going to write that as the partial fractions. So it's a, which is a quarter, x minus 1, plus b, which is minus a quarter, x add 3 dx. Now what I would do with these, I would split these integrals up. Bring that quarter out, there's your first integral. Bring the quarter out, and there's your second integral. Now, to factorize or to integrate a fraction, do I have the derivative on top? The derivative, this is the 1, I have it. So I can integrate that. To integrate a fraction, it goes to log the bottom line. Now, do I have the derivative on top? Derivative is 1. I do have it on top. So you log the bottom line. Now, quite often in these cases, instead of writing plus c, you write plus log c, because everything's in terms of logs. So I could write that as a quarter, and then it is log this number, take away this. If you're taking away the logs, it's the same as dividing them. Plus c. Now, so I can write that as a quarter log. Now, another big trick here, I'm just going to pop this in. I could write that as a quarter log c. And I'll show you why I'm doing that. Because then it means I have got a quarter log x minus 1, x plus 3, plus that becomes a log c. And if you're adding logs, it's the same as multiplying them. So that becomes a quarter log x minus 1, x plus 3 times c. This plus c, you can play around with it, or you can just write it as a plus c. So you could just write that here as a quarter log x minus 1 over x plus 3 plus c. So you can manipulate that to suit yourselves when you're doing that question. But I just wanted to show you a different way of writing it out. If you can't follow that way, don't be stressing over that. The second example, example 2, x plus 1 over x cubed plus 2x squared dx. Now, I always check for the derivative. The derivative of this, if you differentiate that, you get 3x squared plus 4x. I don't have that on top, so I have to go through a different way. And the different way is always your partial fractions. So you have to factorize before you use partial fractions. And that's one of these repeated roots. So it's a over the x, b over the repeat, and c over the bit on its own. Sort out the tops. So it's a, x add 2, plus b, x add 2, plus c, x squared. Choose x to be minus 2. Gives you minus 1 equals, that disappears, that disappears, and that gives you 4c. So c is minus a quarter. choose x equals 0, 0 add 1, 0, 0 add 2, and then terms of 0. So it's, b is a half, and then I would just go for the x squared coefficient. There is no x squared coefficient here. The x squared coefficient there is an a. There is no x squared coefficient in there, and the x squared coefficient is a c. C, you know, is a quarter, so a has to be a quarter. So I'm going to write my integral out using that. So it's going to be the integral of a plus b plus c, which is minus a quarter. Now, I am going to split these up as I did before. So this one becomes a quarter, the integral of 1 over x dx. The next one becomes a half, the integral of x to the minus 2. And the last one becomes 1 over x add 2 dx. Do I have the derivative of the bottom on the top? I do. This one here, you add 1 to the power, divide by it. Do I have the derivative of the bottom on the top? I do indeed. Now, this question had integral limits, so just use those. So putting that in, it's a quarter log 2 minus 1 over 2, and that's x comes in the bottom row, so it's another 2. Take away a quarter log 4. That's subbing in x equals 2. Now sub in x equals 1. Log 1 minus a half, that x pops in the bottom row, minus a quarter log 3. And tidying this up, it's a quarter log 2 minus a quarter log 4 minus log 1 is 0 plus a half plus a quarter log 3. What I'm going to do is I'm going to take a quarter out of everything. So that's going to be log 2 minus 1 minus log 4. Remember, a half is 2 quarters. So if I take a quarter out, I'm left with 2 here plus log 3. This makes it a wee bit easier to tidy up. So log 2 minus log 4, if you're subtracting them, you divide them, times by 3. And then minus 1 add 2 is 1. So that tidies up to give you a quarter log 6 over 4 is 3 over 2 plus 1. Right, the next one I'm going to look at, example 3. I can see a problem with example 3, just glancing here at the screen, because the top is not smaller than the bottom. X squared, x squared. So I have to do my division first. This is not a pleasant question. The bottom line is x squared minus 2x add 1x is minus x minus 2. X squared into x squared goes once, 1 times it. Draw your line, subtract. X squared minus x squared's gone. No x minus minus x becomes 1x. 2 minus minus 2 is 4. X squared doesn't go into that. So you write that as 1 plus the remainder over the divisor. This here has to go into partial fractions. It is a very, very long-winded question. So x plus 4 over x add 1, x minus 2 equals a over x add 1 plus b over x minus 2. Doing out the top row, a over that becomes x minus 2, and this becomes x plus 1. Choose x to be 2, so it's 6 equals 3b, so b is 2. And then choose x to be minus 1 for this one here. Minus 1 add 4 is 3, minus 3a, a is minus 1. So my integral is 1 plus your fraction. Here's all my wee bits here. So a is minus 1 over x add 1. B is 2 over x minus 2. And that's what I'm going to try to integrate. Okay, again, when I'm doing these, I do like to split them up. So it's 1 dx minus 1 over x add 1 dx plus, and I do have a tendency just to bring that 2 outside just to keep it nice and neat and easy to work with. Integrating a 1, you get x. Integrating, sorry, do I have the derivative of the bottom on the top? I do indeed. So just log it. Do I have the derivative of the bottom on the top? I do. So I log it. I had integral limits to put in. And they were a 1 and a 0. So putting in 1. 1 minus log 2 plus 2 log. Now that's going to be a 1 minus 2 is minus 1. But it's a modulus. So you'll just have positive minus 1 in there. Sorry, positive 1. Take away. Putting in 0. 0 minus log 1 plus 2 log 2. Remember, you put in the positive. Okay, so tidying this up. Just checking everything there is as it should be. Right, log 1 is gone. So I have got 1 minus log 2 from the first bracket. Log 1 is gone. So it's minus 2 log 2. So we've got 1 minus 3 log 2. And, oh, that's the answer. Now, I've any more to do in this one? One more to do. Example 4, it's quite long, this. Right, what have we got going on here? This is not pleasant, this one. It's not partial fractions. It's not a bracket, because for a bracket to work, I have to have the derivative outside, which I don't have. Okay, so when you're completely stuck and you've nowhere to go, then look at substitution. It's always my last resort. I hate the substitution one. This is my awkward bit. So that's what you say, let u equal. So du by dx, differentiate that, you get 2. Rearrange it. So du equals 2 dx. So du over 2 equals dx. So take your expression, we'll call it 1, we'll call this 2, and we'll call this 3, and we'll put in all our bits and pieces. X, oh dear, u minus 1 equals 2x, so u minus 1 over 2 equals x. So x is u minus 1 over 2, square root, that is my u. Dx is du over u. Okay, this is not a nice question. So let's start splitting this up a wee bit. Du over 2, and shove that in. There's a quarter. Get it outside, out of the way. So I have got u minus 1 times u to the half du. So just times through your wee bracket there. That's u to the 1 times u to the half. Add the powers. Minus u to the half du. So add 1 to the power, u to the 5 over 2, and divide by it. So same as turning it upside down. Add 1 to the power, divide by it. Have I got limits in this one? No. And just put in plus c. Have everything brackets in there. So timesing that out, it's 1 over 10. Your u from way up here is 1 plus 2x. So it's a square root of 1 plus 2x to the 5 minus 2 over 12, which is a sixth. 1 add 2x cubed plus c.